Hello, my name is Mr. Asprey and good luck with your paper 2 tomorrow. I really hope it goes well. Let me know how it does go. I've decided to do this absolute beast question. It's a MADAS question, it's 20 marks and it covers like 2 forms of integration. So give it a go, but also be wary that this is like a real A-star question. So if you can't do it, then don't fret. Honestly, don't fret. Just watch the solutions and hopefully you pick up something along the way. And then finally, for paper 3, I will do 3 predicted papers, just like I did for paper 2. 1 I'll put onto YouTube, and then 2 I will use in my live session. So do check that out. Link is in the description. Thank you so much for those people that came to my live session last weekend. They sold out really quickly. So if you are interested, do check it out. Do consider it. And yeah, here we go. Good luck tomorrow. And this is a beast question. So good luck. Okay, so the first thing we've been asked to do is to show that the area can be written as that with respect to t. So that means I need to integrate parametrically. So at the moment what I have my limits in terms of x, so I'm going to need to swap those over. So we know the x values are related to t like this. So I can say that 2/3 is equal to 1 over 1 plus t. I could do some cross multiplying there to get 2 lots of 1 plus t is equal to 3. I could then expand that out like so, and then I could subtract the 2 and then divide through by 2. Lovely. And then I could do that as well for the other limit. So that's 2 is equal to 1 over 1 plus t. I could again multiply up like so, and then I can expand these brackets, and then I can subtract the 2, and then I can divide through by 2, and I get the other limit is that t is equal to -1/2. Okay, so now what I can do is I can set up my parametric integral, and the formula is y multiplied by dx by dt dt. And I need to put my limits in, and I've got to be very careful here because naturally I think people might just put the half on the top and the -1/2 at the bottom, but in fact it's the other way round, because you can see here that the 2 is the upper limit, and that comes from that 2 there, and that gives the -1/2. Okay, so -1/2 goes on top and +1/2 goes on the bottom. Right, so before I could do that I need to find dx by dt, and in order to do that what I might do is I might just rearrange the x equation, so I could just write it as 1 plus t to the -1, and then I can differentiate using the chain rule. So the power comes down to the front, we keep the function, the bracket, the same, we drop the power down by 1, and we times by the derivative of the bracket, which is just 1, so I don't need to do anything extra. Okay, let's set up my integral then. So I've got -1/2 on top and I've got 1/2 on the bottom. The y function is 1 over 1 minus t, and the dx by dt is negative, and I can actually rewrite this now. It's more useful actually to have just -1 on top and then 1 plus t on the bottom, and that'll be squared because it's a negative power. So that is open brackets -1 over 1 plus t close brackets, or open brackets close brackets, dt. Okay, great. Right, now the little trick, which actually I did in my predicted paper I think, so that's twice I've done this trick. Makes me think maybe it might come up tomorrow, and that is that if you have a negative function you can replace it with a positive function, and that will swap the limits over. So swapping the limits like that and then getting rid of the negative will give me what I need, which is just 1 on top, so not -1 anymore, and then on the bottom we've got all these denominators which when multiplied together give me exactly what I've needed to prove that the area was equal to. Okay, great. And now it says find the exact area. So I've only done like a part of this question so far, or part of this part actually. And now what we're going to need to do is we're going to need to use partial fractions. So let me put this up to the top. In fact, I can get rid of it because it's to show that question. Okay, so partial fractions. Okay, let's get started. 1 over 1 minus t, 1 plus t all squared is equivalent to a over 1 minus t plus b over 1 plus t plus c over 1 plus t all squared. So if you have that repeated root situation like this, where you've got a bracket on the bottom which has a square or a cube, I can't imagine it would be a cube, but most likely a square, then you need to write out the linear root and the linear factor, and also the quadratic factor like that. Then we multiply through by the denominator on the left, and that's going to cancel this denominator here, 1 minus t, and it's also going to give us an extra 1 plus t all squared. And then multiplying through here gives me b, and it's going to give me 1 minus t and 1 plus t. And then when we multiply through with the c, it's just going to give me 1 minus t. Lovely. Okay, so we need to select t values which are going to knock out some of these brackets. So the first one I'm going to do is I'm going to select t is equal to 1. Left hand side will stay the same because it's not a function of t, it's just a constant. And when I sub in t is equal to 1, it's going to knock out this bracket because of the 1 minus t, and that bracket as well. So I'm just left with the a bracket, and that will be, when I sub in 1, it will be a multiplied by 2 squared, which is 4. Divide through by 4, I get a is equal to a quarter. Okay, next thing to do is try minus 1. That's going to knock out, what brackets is that going to knock out? It's going to knock out the 1 plus t brackets. So those are going to go. So I'm just left with the c. And when I sub in minus 1 to the c, I'm going to get 1 minus minus 1, which makes 2. So I'm going to get equal to 2c, so therefore c is equal to a half. And then finally, we've got no other brackets that we can knock out because we've used all of them up. So we just sub in the easiest number possible, which is 0. And that is going to give me an a. It will give me b. And it will give me c. And then I know that a already is a quarter. And I know that c is a half. So all in all, that means that b must also be a quarter. So they all add up to 1. Okay, great. So now I can transform my integral, which I'll just call I like that. And I will say that that integral is now equal to, after partial fractions, that gives me, I'll put it in a bracket like this, because they're all separate. Well, where are we? Aha, actually, we've got a quarter here, haven't we? We've got a quarter coefficient, and we've got a half coefficient. So let's just take out a quarter. And then that means that a is now essentially 1. So 1 over 1 minus 2t. And it means that b is essentially 1 on top, because I've taken the quarter out. And that's 1 plus t. And then c is a half, but I've taken a quarter out, so that's going to leave me 2. And I'm actually going to write this one as 1 plus t to the minus 2. Just because I know it's not going to integrate to a ln, and it just reminds me not to like ln it by mistake, and I'm just going to use the just a standard integration technique to integrate that one rather than the ln method. Okay, so now we need to integrate these, don't we? Yes, we do. So the quarter stays outside. This one here, there's a negative on the bottom, so the derivative of the bottom is minus 1, which is not quite the top. So I'm going to take a minus out in order to make it so. So it's minus 1 minus, it's minus ln 1 minus t. Next one is perfect because the denominator's derivative is the numerator, so I could just go straight in and just say that is ln 1 plus t. And this one, I'm just going to use standard techniques because it's a linear function, so I'm just going to up the power, which goes to -1. And then I'm going to divide by the new power, so dividing by -1 will change the sign to a minus, and then divide by the derivative of the bracket, which itself is 1, so that doesn't need to be done. Okay, so half and minus a half. Right. Okay, we're back. And there we go. So I is now, we need to just substitute in the values, don't we? So I'm going to take a quarter here. And this is going to give me minus ln of a half. That's going to be plus ln of 3 over 2. And this is going to give me a half, 3 over 2, swap it over 2 over 3, times it by -2, gives you -4 over 3. Okay, now I'll take away the negative, subbing in negative a half, and that's going to give me minus ln of 3 over 2, and then plus ln of a half, and then that's going to give me a half inside the bracket, flip it over because it's the reciprocal, so 2 times by -2 is -4. Lovely. Okay, let's keep the quarter outside, and then let's simplify these. So we have a minus ln a half and another minus ln a half. So that is -2 ln a half. And we have a positive ln 3 over 2, and then another positive ln 3 over 2 because that double negative there. And then we have these terms here will be -4 over 3 plus 4, which will give me 8 over 3, so plus 8 over 3. Fantastic. And what can we do next? Yes, I mean we can multiply through by the quarter, can't we? And we can connect up these lns as well. So because we have one which is a negative, like this, and one which is a positive, we can divide the inputs. So that is going to give me 3 over 2 divided by 1 over 2, which is just 3. So I'm going to get a quarter 2 ln 3 plus 8 over 3. And now let's times through by the quarter. I get a half ln 3 plus 2 over 3. Okay. And that's part A done. Oh gosh, why did I pick this question? Okay, part B. Let's go. It says determine the Cartesian equation of the curve. Okay, so I'm going to start with the x, and then I'm going to rearrange for t. So I'm going to multiply, I'm going to swap over the x and the 1 plus t, basically, just by multiplying and then dividing. So 1 plus t is equal to 1 over x. And then I'm just going to subtract 1 like that. And then, generally speaking, I like to keep it as a single fraction. So that is the same as 1 over x minus x over x, which is the same as 1 minus x over x. Okay, now let's look at the y and let's substitute in for t. So this is going to be 1 over 1 minus over x. And then I'm going to multiply top and bottom by x. So all three terms here by x. That gives me 1 times x is just x. And then here I'm going to get minus 1 minus x like that. So this gives me x. And then I've got 2 negatives there. So that's going to be another x, so it's x minus x, that's 2x, and then I've got minus 1, like so. Okay, so that's the Cartesian equation. Okay, so that is the equation that I'm going to need to integrate. So let's put that up there. Okay, so the region is also equal to the integral, and this time I'm going to do it with respect to x, so I'm going to use the x limit, so that's 2 and 2 over 3, and that is x over 2x minus 1, and that is dx. Now, this is an improper fraction, and an improper fraction is when the numerator's highest power is at least or more than the denominator's highest power, and in this case they're both x to the 1, so this is improper fraction. And the way that I recommend integrating these would be to divide the numerator by the denominator. So over here I'm going to do a polynomial division, which might seem a little bit strange because it's such a small division, but I'm going to divide x by 2x minus 1. Okay, so what do I get when I divide x by 2x? Well, I get half, or 0.5. Then multiply down, like so. And 0.5 times 2x gives me x, and then that gives me minus 0.5. And then we subtract, and I'm going to get 0 minus 0.5, so I'm going to get 0.5, or half. So that tells me that the integral is the same as a half, because that's what I got when I divided. I'll write it like this now. And I also got left over a half, so that still needs to be divided. So it's a half over what I was dividing by. Okay, great. Let's take a half out to tidy it up somewhat. That gives me 1 plus 1 over 2x minus 1 dx. Oh my gosh, what a beast question. Okay, so now that we can integrate directly, and that will give me x, and it will give me, well, it's not quite the derivative of the numerator of the denominator on the top. It's actually a half of it, so it's going to be a half ln 2x minus 1, and that's between 2 and 2/3. Okay, so now it's time to sub in our limits. Okay, so let's see if I can do this again, all without a calculator, just for the bants. Okay, so this is going to give me 2 plus a half ln of 3. That's what I get when I sub in 2, and then minus, when I sub in 2/3, I get 2/3 for x, and then plus a half. 2/3 times 2 is 4/3, minus 1 is 1/3, so ln of 1/3. Okay, great. So let's write them all out now. So I've got, well, let's actually do them as individually. Let's do this like this. So 2 minus 2/3. That's nice and straightforward. That is 4/3. And then I have, again, because we've got the same coefficient outside, we've got this half ln 3 minus a half ln 1/3. I can write that as a half of ln and then 3 divided by 1/3, which is 9. Okay, this is looking good. Multiply through, that gives me this, and then I can show that they're the same because this is a half times a half ln 9, and one of the halves there, doesn't really care which one, can come up to be the power of the logarithm of the input like that, and of course 9 to the power of a half is 3. And that is the same as the first one. Yeah. The crowd goes wild. Okay, right, I hope you enjoyed that. Check out my live session for paper 3, link in the description, and good luck tomorrow. I really hope you do well. Let me know how it goes. Bye for now.